In this course, the course is EMM 304, and we want to look at the method of separation of variables. So here we look at the solutions to differential equations using a method we call separation of variables. So this method is applicable to differential equations that can be expressed in the form dy dx is equals to phi of x times psi of y, where in this case phi of x is a function of x only and psi of y is a function of y only. Now, to solve this kind of a differential equation, we use a method that we call separation of variables. What we mean by this method is that you take all the terms that contain x and put them on one side, and anything that contains y, put it on the other side. Then we shall just use now the direct integration. So this can be achieved by first multiply both sides by dx, so that we write dy is equals to phi of x times psi of y multiplied by dx. And then at this point now we divide both sides by psi of y, so we divide here by psi of y, and we divide here by psi of y. So psi of y is going to cancel out on the right hand side, and our differential equation will become 1 over psi of y is a function of y alone, dy is equals to phi of x times dx. So that on the left hand side we have a function of y, and on the right hand side a function of x only. So y does not appear anywhere on the right hand side, neither do x appear anywhere on the left hand side. In that case, we say that we have separated the variables. And at this point now we introduce the integral. So we write the integral of 1 over psi of y dy is equals to the integral of phi of x dx. So now if the function psi and phi are known, then we can perform integration, and what we get is the general solution of the differential equation. So we're going to take an example. We have an equation of this kind, which we can write as 3xy squared dy, 3xy squared dy plus xy minus y dx is equals to 0. So in this equation, we can first move the second term to the right hand side, so that we write 3xy squared dy is equals to minus xy minus y dx. On the right hand side, I'm going to factor out minus y, so that I'll write minus y. Then I have, or let me just factor out y. So that I avoid confusion. Y, then I have, so in that case I'll have minus y in this case, because there is a negative. Note that there is a negative here. So when I factor out y, then I'm going to have minus y. Then I'll have x minus 1 dx. And on this side, we still have 3xy squared dy. Now if I divide both sides by y, so that on the left hand side, I divide here by y, and on the right hand side I have minus y into x minus 1 dx. I also divide by y. You see that on the right hand side y will cancel out, and on the left hand side we have y squared divided by y will give me y, so that I'll get 3x y dy is equals to minus x minus 1 dx. At this point I can then divide both sides by x, so I divide here by x, I divide here by x. So the left hand side I will get 3y dy is equals to minus x minus 1 divided by x dx. So you notice that now on the left hand side I only have the variable y. I don't have x anywhere appearing on the left hand side. On the right hand side I have the variable x only. Y does not appear anywhere. This is, at this point we say now we have separated the variables, because we have y on one side, we have x on the other side. So in this case we say that we have separated the two variables, x and y, and we can now introduce our integral. So right now the integral of 3y with respect to y is equals to the integral of minus x minus 1 all over x, and this one I'll integrate with the respect to x. I have that. Notice that the right hand side I can write minus x all over x plus 1 all over x when I divide by x through, so that I have and I want to write the right hand side also, so that we don't lose track. And now I'll have the integral of 3y dy with respect to y is equals to the integral. I want to start with this quantity here, then minus x over x is minus 1. So I'll write 1 all over x minus 1, and this one I'll integrate with respect to x. The integral of 3y will give me 3 all over 2 y squared, which will be equals to the integral of 1 over x is ln of x, the logarithm of x, and the integral of minus 1 is minus x. Then I have c, the arbitrary constant of integration. So I can write the result down here again. 3 over 2 y squared is equals to ln of x minus x plus c, which is now the general solution of the differential equation. So note that before we start integrating, the key thing here is that we must separate the variables, so that on the left hand side we have only the variable y, and on the right hand side we have the variable x only. So don't start integrating at a point where we have x and y. Like in this case here, we cannot introduce the integral because we have two variables x and y. Integration is not possible. So we will first completely separate the variables x and y. Once you have achieved that, you can now start integrating, and the rest is just to integrate the normal way. So basically this is the method that we call the method of separation of variables.